Hello, and welcome to the Compute Keynote for reInvent 2020. My name is Dave Brown, and I'm the Vice President for Amazon EC2. This is my 8th reInvent, and it is always an exciting time for us and our customers. While things are a little different this year, we still have an enormous number of exciting new announcements, and I'm still excited that we could be with so many of you here in a whole new way. Well, we have an action-packed hour ahead of us, so let's get going. To say 2020 has been an unprecedented year is an understatement. COVID-19 has impacted us all. The way we learn, the way we work, the way we entertain, the way we go about our lives. Our commute times and carpooling duties were replaced with finding a quiet place to take video calls and ensuring our kids turned in their virtual homework assignments. Safer at home and shelter-in-place mandates led governments, schools, businesses to quickly implement secure and reliable work-from-home solutions. This put pressure on IT leaders to respond quickly to scale their businesses and meet demands like moving from in-person interactions to transactions online. All of this also led to an enormous demand in cloud services, providing organizations with the agility that they needed to support new workloads. AWS has been able to respond quickly by helping to provide scalable and reliable infrastructure capacity and support our customers. Across many industries, companies have looked to the cloud to ramp to massive scale to take their business operations online. Blackboard, a leading edtech company servicing students, businesses, and governments around the world, were faced with a 3,600% increase in demand overnight. We were able to help them scale 50 times in EC2 capacity to ensure that students around the world migrated from in the classroom to online learning. Customers supporting remote work, such as LogMeIn, had to suddenly scale to levels that they had previously never expected as everyone moved to work from home. Epic Games, known for their industry-leading games like Fortnite and Rocket League, saw a rapid increase in usage across the gaming platform. We were able to help them scale to meet this demand, along with hosting some of the world's largest online events, consisting of millions of players. Vyaire, a global medical company that manufactures, sells, and distributes over 20,000 respiratory care products and solutions found in ambulances, operating rooms, and nursing homes, this year demand for their medical products hit an all-time high, which saw Vyaire increase from about 30 units per week to almost 1,000 per day. Vyaire migrated to AWS to increase ventilator production 20 times, helping first-line responders treat critical conditions due to COVID-19. It is during these unprecedented times that technologies are tested to see if they can scale to meet the demands of increased usage, higher performance, reduced costs, and changing customer needs. Within EC2 and the broader AWS, we moved to work from home in early March. Our existing tools and use of cloud services supported us well as we transitioned to what has now become the new normal. Like many of our customers, through this, we had been able to maintain and accelerate our pace of innovation. So far in 2020, we have had over 160 new launches, including more than 100 new instances and 130 new feature releases. Our customer focus, our pace of innovation, our proven track record, and our long-term focus is what sets AWS apart. Andy Jassy has often said there is no compression algorithm for experience, which is especially true when it comes to learning to operate at cloud scale and ensure that we provide the best technology platform to our customers. Gartner's latest Magic Quadrant is a testament to our leadership for the 10th consecutive year. Gartner has placed AWS as a cloud leader in the Cloud Infrastructure Platform and Services Magic Quadrant. So, how did we build this platform that scales for unprecedented times? Our vision is to build the compute platform for virtually every workload and every need. We built this massive compute platform for you, pushing the limits on security, pace of innovation, and delivering the best performance at the lowest price, enabling support for diverse workloads and extending the cloud to where you need it. So with no further introduction, let's start with how we built this platform to push the limits on the fundamentals. AWS Nitro System is the foundation on which we were able to deliver industry-leading security, performance, and innovation. Traditionally, hypervisors have a lot to do, including protecting the physical hardware, firmware, BIOS, virtualizing the CPU, storage, networking, all while providing a rich set of management capabilities. After spending the early years of EC2 optimizing traditional virtualization systems to the point of diminishing returns, we knew we had to do a dramatic change of our architecture if we were going to continue to provide the performance and security that our customers were looking for. This realization forced us to rethink everything about virtualization and compute in the cloud and became the spark for us to create the Nitro system. Over a period of 5 years, we worked to develop the Nitro system by breaking apart virtualization functions, offloading them to dedicated hardware and software, and reducing costs by delivering practically all of the resources of a server to your instances. While we began rolling out components of the Nitro system as early as 2012, it was only in 2017 that we launched our first instance that was fully controlled by the Nitro system, our C5 instance. Now with the Nitro system, we can offer the world's most secure cloud environment, the best performance at the lowest price, and not only more innovation, but also at a faster pace. The Nitro system is unique to AWS, and it is the platform for building our latest generation of instances. Although it was only launched 3 years ago, the Nitro system today is used for over 70% of instances within EC2. Let's take a closer look at the security within the Nitro system. At AWS, security is our #1 priority. So when it comes to reinventing virtualization with the Nitro system, we made security our #1 priority as well. The Nitro system has been engineered with a hardware-based root of trust using the Nitro security chip, allowing us to cryptographically measure and validate the system continuously. This provides a significantly higher level of trust in what is running than can be achieved with traditional hardware. Earlier, I mentioned the most of the virtualization resources are offloaded to dedicated hardware and software. This not only makes the hypervisor more lightweight and efficient, but it also makes it more secure because the attack surfaces and vulnerabilities are minimized. Finally, the Nitro system offers a lockdown security model that prohibits all administration access, including those of Amazon employees, eliminating the possibility of human error and tampering. And this is just the baseline of the security built into our platform, available to virtually any workload. Now, a platform should not only be secure, but also have security features that are easy to use. Our customers are looking for ways to more easily process their highly sensitive data, so we thought we could help. Recently, you may have heard of terms like confidential computing, or trusted computing, or isolated computing. Well, regardless of the terminology used, it is about making processing of highly sensitive data more secure. Today, customers use Amazon EC2 to process a range of highly sensitive data, such as personally identifiable information, healthcare records, financial data, intellectual property, and more. They protect this data with access controls and encryption when it is in rest and in transit. But what happens when this data needs to be decrypted for processing? Customers set up separate VPCs, remove unnecessary third-party software on the instances, limit connectivity, restrict user access, and more, just to isolate the processing of this sensitive data. Well, we wanted to make it a whole lot easier. So last month, we announced Nitro Enclaves that simplifies this, enabling you to easily create fully isolated compute environments called enclaves to isolate processing of your highly sensitive data. To better understand what Nitro Enclaves are all about, I caught up with Colm McCarthig, Senior Principal of EC2, to talk more about our Nitro Enclaves. Let's take a look. Well, welcome, Colm, and thank you for joining us here today. We launched Nitro Enclaves just a few weeks ago now. And can you maybe start off by telling us what is the difference between a Nitro Enclave and a normal EC2 instance?
Yeah, so Nitro Enclaves help customers protect their sensitive data while it's being processed. And they're actually created from the existing resources on an EC2 instance. But we take those resources and we create a highly isolated virtual machine that's got no durable storage, no access to external networking, and it's got a very, very small surface area that's exposed to any kind of attack. And in fact, even the root user or admin users in the EC2 instance can't see inside that enclave, can't read its memory, don't have any visibility of what's going on. The only communication between that instance and the enclave is a secure local channel called a VSOC.
Wow. So we've actually brought a lot of the security that we built into the Nitro system and brought that up into the application level to allow our customers to use it. And so aside from the isolation, what are some of the other benefits of Nitro Enclaves that you'd like to highlight?
Yeah, so isolation is definitely the biggest benefit of Nitro Enclaves, but Enclaves have also been designed to be very flexible and easy to use. Because they're provided as a virtual machine, they're compatible with any programming language or framework and very easy to use with almost any programming model. And second, Nitro Enclaves use robust, simple CPU-based isolation technology for protecting the instances from one another, but that's also combined with the unique design of the Nitro system to provide a root of trust that's rooted in AWS designed silicon. And in fact, based on that, we're including cryptographic attestation, where the Nitro system can verify the identity of your application and then use that verified identity for first-class integration with our key management and certificate management services.
Wow, that's fantastic. So we actually only launched Nitro Enclaves just a few weeks ago, but I'm interested to hear, what has the customer response been like so far?
So the customer response has been great. We've had customers thrilled with the format and interface that Nitro Enclaves provides. We've had customers such as Anjuna and CAS Labs and Evervault building applications on top of Enclaves already. So far, the feedback has been that the Enclaves model is simple and easy to use, and that folks can get running quite quickly. For those customers, securing data is a big part of what they've been doing for a long time. And so to have a managed, secure environment available that can keep that sensitive data processing isolated is an enormous simplifier.
Well, and so the simplification we've brought to Nitro Enclaves has really opened us up to a much broader customer base to be able to use this, whereas previous solutions would have been much more complicated to adopt. Can you tell me more about how customers can get started with Nitro Enclaves?
Yeah, so Nitro Enclaves is free to use. There's no cost or charge to customers beyond what you're already paying for your EC2 instance. And it's now generally available, so our documentation and our material is all there on our website. Just search for Nitro Enclaves. And we've also got a number of reference and open source Nitro Enclave applications available in our GitHub repository, including our own ACM for Nitro Enclaves application. So it's pretty easy to take those and get going.
Fantastic. So really simple to get going. Well, Colm, I know we're both very excited about Nitro Enclaves and see what customers are going to do with it. And just thanks again for coming in and talking today.
Thank you.
As you can see, we're super excited about Nitro Enclaves, especially the ease of use and the level of security that it brings to your application environment. Another important benefit of the Nitro system is enabling better performance for your workloads. Before we dive deep into how we are able to offer better price performance and choice, let's consider what better price performance actually means. For a lot of workloads, customers are looking for better raw performance. At the same time, they're looking for the lowest cost instances or compute. Price performance is all about giving you the best possible performance for every dollar you spend. Nitro-based instances are able to offer better price performance across CPU, networking, and storage because we offload management processes to lower cost dedicated hardware. Not having to hold back resources for management software means more savings that can be passed on to customers in price performance. It's only the Nitro system that allows us to have the broadest selection of processors in the cloud, with the very latest cores from Intel, AMD, and our own ARM-based processor, Graviton2. Intel have been with us from the very beginning of EC2, and today the majority of our instances continue to be powered by the very latest Intel processors. These are not simply off-the-shelf Intel Skylake and Cascade Lake processors, but we have partnered with Intel to bring you processors that provide the highest sustained all-core turbo frequency, allowing customer workloads to run faster. We're excited to announce a number of notable new instances with Intel at reInvent this year. A new high-frequency instance, our M5ZN, an EBS-optimized instance, R5B, offering 60 gigabits of bandwidth and 260K IOPS of EBS storage, and a dense storage instance, D3 and D3EN, that offer up to 336 terabytes of local hard disk drive storage. We launched our first AMD instances in 2018, powered by the AMD EPYC processors and delivering 10% improved price performance for x86 workloads. Customers have loved the simplicity of migration and the opportunity to save 10% price performance with very little effort on their part. And now, let's take a look at a processor that is only available to AWS customers and provides price performance benefits that are seldom seen in the industry. Graviton2, our ARM-based server chip, designed and built by AWS, delivers 40% better price performance than the current generation of comparable x86-based instances. That's 40% better raw performance and 20% lower cost. Last reInvent, we announced 3 new instances on Graviton2, M6G, R6G, and C6G, which are now generally available along with additional disk-based variants. A few months ago, we launched T4G, offering the lowest and best price performance for burstable workloads. And new, just at reInvent, we launched the C6GN for compute-intensive workloads, such as high-performance computing. C6GN instances deliver up to 40% better price performance compared to C5N instances, along with 100 gigabit networking and support for elastic fabric adapter, and are targeted at applications such as data analytics, network appliances, real-time video communication, and high-performance computing. From the start, we knew that growing a strong ecosystem to support ARM-based workloads was going to be critically important. We worked closely with operating system and independent software ecosystem partners to drive support for the 64-bit ARM architecture. Support for ARM in the open source software community was already pervasive, but AWS building ARM-based processors at scale has helped galvanize the rest of the ecosystem, prioritizing ARM support. We have also brought ARM support to container-based workloads with support for both ECS and EKS, and have a growing number of AWS services that are integrated with Graviton2. In my conversations with customers, many are concerned about the complexity of moving to Graviton2, but in almost all cases, the migration is much simpler than they expected, and they're reaping the 40% price performance benefits before they know it. Here are a few of the thousands of customers that have adopted Graviton2 instances for their production workloads. Customers like Nielsen, Ancestry.com, CBS, Datadog, and LG Electronics have migrated and have seen the benefits of Graviton2 and what it has to offer. Earlier this week, I spent some time with Don McCaskill, the CEO and chief geek of SmugMug and Flickr. SmugMug is an early adopter of Graviton-based instances and has been with us on the Graviton journey from the very beginning. Let's see what Don had to say. Well, welcome, Don, and thanks very much for joining me today. You know, we've had a long and fantastic history with SmugMug. I think you were one of our very first S3 customers. I've been working with you on EC2 over the years. And you know, we're here today to talk a little bit about Graviton and what you've been doing with Graviton at SmugMug. And so maybe we can start off about what made you interested in Graviton to start with.
Yeah, well, thank you so much for having me. It has been a fun journey getting here to ARM on AWS. I think we got interested in ARM about a decade ago because we knew that for so many of our workloads, the price performance would be way better on ARM than it was in traditional server data center processors. That's primarily because many of our workloads are just not very CPU intensive. They're often I/O bound, so they're busy shuffling, bytes in and out of network interfaces or storage or memory or things like that. And so for a long time, it's felt like we were wasting cost and power on CPUs that were essentially partially idle. And so when we found out that Graviton was coming, we got really, really excited. We've been interested in this for a long time. And as soon as it came along, we discovered that absolutely, it was an amazing fit for many of our CPU-light workloads that needed to move a lot of data around. And then things really took a turn for the better when Graviton 2 came out, because all of a sudden, even our CPU-intensive workloads were operating faster on Graviton 2 than they were on traditional processors. It was pretty amazing.
That's fantastic. And Don, with Graviton 1, one of the things we were really focusing on was triggering that ecosystem, making sure that the ecosystem was there to be able to support workloads running on Graviton. And so from an ecosystem point of view, can you go into more details on how easy was it to actually use Graviton?
Yeah, so we were really excited about this project, but we thought it would be kind of pretty hard. We were switching CPU architectures. And instead, we had our first large-scale workload up in about 2 weeks because the Linux ecosystem was already well prepared for the advent of ARM. Linux has been on small and embedded devices running ARM for a long time. And so most of our 2 weeks wasn't spent doing heavy lifting so much as it was spent just testing every layer of the architecture to make sure that all of the packages we found already pre-compiled for ARM actually worked well and were bug-free and stable and fast. And so we found out that that was indeed the case. So 2 weeks later, we went into production, and we haven't looked back since.
That's amazing, Don. And I actually remember when the launch of Graviton 2 happened, I think it was the very next day that you actually tweeted and said, hey, we've just migrated to Graviton 2. It literally was one day.
Yep, it was literally one day. That was really fun, the team was really excited about it and kind of charged off to do it without me even knowing that was happening. And so it was great to just kind of find out later in the day that Graviton 2 launched and we already have a large-scale workload up on it. And even in just the last couple of weeks, we've moved, I think, 3 or 4 major big workloads. The vast majority of compute at Flickr is now on Graviton 2. We have a couple of services that we're still in the process of moving, but that's going really, really well. The teams are just knocking them down left and right. It's awesome to see.
It's just amazing. And obviously all of that comes with a 40% improvement on price performance across your fleet. Don, as we think about other customers, I talk to a lot of customers and they think about moving to Graviton might require a lot of work on my side. We have to recompile. With the experience you've had, what is your advice to other customers looking to maybe embark on the same journey?
Yeah, I mean, being able to save 40% without basically doing anything other than a recompile or a new Docker build or something is pretty incredible. No contract negotiations, no fiddling. It's pretty simple. So if you have workloads like ours, Linux-based workloads, especially on sort of rich modern languages like PHP, Python, Java, that sort of stuff, like it's so simple. I've never ever in my career seen saving 40% be this easy.
Well, Don, that's amazing. Just incredibly exciting to hear what you've been able to do at SmugMug and now Flickr as well with Graviton 2. And I really just want to thank you again for joining us today and sharing the story. Thank you.
My pleasure. Thanks so much for having me.
It's always great catching up with Don and seeing the excitement that he has for ARM and Graviton 2, and just what it has done to improve the price performance at SmugMug and Flickr. Now let's take a look at some of our accelerators. Like processors, we have the broadest selection of accelerators in the cloud. We have the very latest NVIDIA GPUs, Xilinx FPGAs for custom hardware acceleration, and another AWS custom chip, Inferentia, targeted at inference workloads. Today, many of these accelerators are used for machine learning, another workload that has seen a sharp increase during these unprecedented times. Today, AWS provides a broad set of instance options for machine learning. For training, the process of teaching your model how to perform a task such as image recognition, we have our R5 memory-optimized instances for CPU training, and our P3 instance offering up to 8 NVIDIA V100 Tensor Core GPUs and up to 100 gigabits of networking throughput for the largest and most demanding ML applications. Last month, we announced the P4D instance. Powered by the latest NVIDIA A100 GPUs, they provide up to 2.5 times better deep learning performance and 25% more GPU memory. P4D instances are deployable as ultra clusters, which are thousands of cores deployed together to more easily allow a user to help tap into the benefits of a supercomputer at cloud scale, along with 400 gigabits of network throughput between nodes. P4D is a powerful offering, providing the highest performance for ML training in the cloud. Now let's take a closer look at what we have been doing to reduce the cost of inference. For inference, the process of deploying the model and leveraging the trained model to assess real-world data, we have C5 compute-optimized instances for CPU-based inference, and our G4 instance offering the latest generation NVIDIA T4 GPUs, up to 100 gigabits of networking throughput, and 1.8 terabits of local NVMe storage. Last year at reInvent, we announced AWS Inferentia and our Inf1 instance. AWS Inferentia is our first custom silicon designed to accelerate deep learning models. Inferentia is designed to provide high-performance inference in the cloud, to drive down the total cost of inference and make it easy for developers to integrate machine learning into their business applications. Our Inf1 instance provides up to 3 times higher throughput compared to our G4 instances, while lowering the cost per inference by up to 40%. That's an incredible saving. These instances also provide support for popular frameworks including TensorFlow, PyTorch, and MXNet. Condé Nast, a global media company with over 20 leading brands including Wired, Vogue, and Vanity Fair, integrated Inferentia chips into their recommendation engine by using Inf1 instances with SageMaker. They were able to reduce their compute costs by 72% relative to the previously deployed GPU instances. Another incredible saving. And one of our most well-known customers, Alexa, announced they were moving the processing of their voice responses to Inf1 last year at reInvent. And they've already migrated 80% of their voice traffic to Inf1, reducing the cost of inference by 30% and improving latency by a full 25%. If you ask Alexa a question, there's a good chance that she'll be speaking back to you with the help of Inferentia. It's been amazing to see the success that these customers have had with Inferentia, improving performance and reducing costs. However, we started with inference since it makes up 90% of the cost of machine learning and deep learning, so reducing costs there made huge impact. But we need to focus on reducing the costs of training as well. So today, we're happy to announce Habana-based EC2 instances. Habana Gaudi accelerators from Intel will offer up to 40% better price performance over current GPU-based instances for training deep learning models. They will also support common ML frameworks like TensorFlow and PyTorch and allow customers to iterate and train models more frequently. Habana-based instances will be available in the first half of next year. And like compute and inference, we're continuing to invest in our silicon to drive down the cost of ML training. So earlier today, we introduced AWS Trainium, a machine learning chip custom designed by AWS for the most cost-effective training in the cloud. Trainium-based instances will offer more TFLOPS compute power than any other machine learning instance in the cloud. Again, Trainium will support all major frameworks, including TensorFlow, MXNet, and PyTorch. Trainium-based instances will also use the same Neuron SDK as Inferentia instances for ML inference, making it easy for developers using Inferentia to get started on Trainium quickly. So, that rounds out our offerings in the ML space, providing the largest selection of ML instances in the cloud. We're really excited about what we have been able to deliver here. For more details, make sure you catch Swami's machine learning keynote next Tuesday. Finally, Nitro enables us to innovate in instance design at an ever-increasing pace by providing basic building blocks that we can assemble in different ways. Today, we have close to 400 instances within EC2, and you can see the pace of innovation here over the last 10 years. We launched our first Nitro-based instance at the end of 2017, and you can see the increase in instances delivered since then. Across these 400 instances, we have the broadest and deepest selection of instance types. We have the broadest selection of instance categories, targeting every possible use case and capabilities across each of those for your every need. Added to that, we support multiple operating systems, including Linux, Unix, and Windows. However, there's one commonly used operating system that is missing from the list. macOS is used broadly around the world today, but has never been available in the cloud. I love my Mac, so this is a hugely important announcement for me. Today, millions of Apple developers rely on macOS and its innovative tools, frameworks, and APIs to develop, build, test, and sign apps for Apple's industry-leading platforms that serve more than 1 billion customers globally. Until now, development of these apps for the Apple platform wasn't possible in the AWS cloud, and many of our customers need to manage a fleet of Macs for their build processes. Over the last year, we have been working closely with Apple to bring Mac to the cloud, and Monday night we announced general availability of Amazon EC2 Mac, allowing you to run Mac workloads in the cloud. Customers can now seamlessly provision and access macOS compute environments to enjoy fast app builds and convenient distributed testing without having to procure, configure, operate, maintain, and upgrade fleets of physical computers. The availability of Mac instances extends the flexibility, scalability, and cost savings of AWS to all Apple developers, offloading the heavy lifting that comes with managing infrastructure to AWS, and allow Apple developers to focus on building great applications. If you would like to know how we pulled this off, I encourage you to catch Peter's keynote on Thursday. where he will pull back the sheet metal on an Amazon EC2 Mac instance and show you just how the Nitro system made this possible. It's pretty amazing. Oh, and we're already working on bringing you the very latest Apple M1 chip, which will land next year. Amazon EC2 Mac instances is just another example of the pace of innovation with the Nitro system. Now, let's move on to the next section. Every day, millions of customers trust AWS to run their business-critical workloads. As I said earlier, COVID impacted all of us and brought unprecedented demand to the cloud in a very short space of time. To support our customers and their businesses, we needed to scale to meet the demand and ensure that we could support new workloads from the financial markets to medical research to scaling for video conference applications. For a first-hand account of what some of our customers experienced and how we were able to help, let's take a look at the next clip.
Since all the lockdowns began and all the stay-at-home orders began, we saw a tremendous increase in the number of people who were using Fortnite and Rocket League. We rely heavily on AWS to help us manage that scale.
We've had to spin up quite quickly a large GPU cluster in AWS and then get this up, get it running, and see the value it can deliver so that we can then feed that value back and work on how we can look to extend those types of compute jobs. We got that up in kind of record time, including all of the complexities around networks and architecture, etc.
Earlier this year, and in accordance with local laws, the COVID pandemic grounded our autonomous vehicles for a few months. And with engineering efforts continuing uninterrupted, this drove a step function increase in demand for our simulation systems. AWS was able to help us access greater volumes of GPU compute resources to meet the demand from our simulation systems.
For video in 2020, especially in March, we needed to scale. For that, we were leveraging on the capabilities of EC2, especially the C5 lineup, because the C5 lineup gives us predictable network performance and predictable compute performance.
The ability to offload work to AWS not only relieved the pressure on the current on-premise plant, but also provided the ability to scale up on demand. So they too can take advantage of the elasticity, which compute products like EC2 provide.
It's great to see how our customers were able to meet the challenge their businesses faced during this time, and how we were able to assist. In this section, I'd like to focus on three things. First, how we were able to deliver capacity to our customer needs based on years of experience in running the world's largest cloud. Second, how we're scaling to support our customers with some of their largest business workloads. And finally, opportunities that our customers have to optimize their workload, typically for cost savings during these challenging times. Let's start with capacity. As I said earlier, the pandemic brought many challenges, and solving many of them required large amounts of compute capacity. For example, one of our financial customers, FINRA, an organization that governs the brokerage firms and exchange markets in the United States, has seen market volumes increase by 2 to 3 times since the start of the pandemic. AWS has been able to meet FINRA's demand for these volatile workloads, allowing them to automatically turn on and off up to 100,000 nodes in a single day. This is just one example of the thousands of customers that we were able to work with to ensure that they had cloud capacity when they needed it. To find out a little bit more about what went on behind the scenes at EC2 in providing this capacity for customers, I caught up with Scott Sikora, Director of the Capacity and Forecasting teams within EC2. Let's take a look. Well, welcome, Scott, and thank you for joining me here today. Can you tell us a little bit about what you do at AWS?
Sure. My name is Scott Sikora. I'm Director for EC2 Capacity. My job is to make sure that when a customer needs 1,000 M5 large instances in the Sydney region, that all of the hardware is there and configured correctly so that they can actually launch 1,000 M5 large instances. To do that, we work very closely with our AWS forecasting team that provides us a forecast every week of how many M5 instances we think we're going to need in Sydney. We do that weekly, and then we turn over that forecast to our infrastructure partners, who take that forecast to make sure that we get the supply chain all configured so that every week we've got M5s landing in the Sydney region to meet customer demand.
Great, and 2020 has been quite the year, right? With the pandemic, a massive increase in demand for cloud capacity. We heard stories about several cloud providers struggling to provide their customers with capacity. AWS was able to meet that demand. So can you take us back to February and let us know what you and your team were going through as we started to see this massive increase in demand for cloud resources?
Yeah, 2020 has been quite the year for us. And many of those models that we had, that we spent all that time tuning, started to break down a little bit. What we saw is a lot of our customers really scale up quite dramatically. Customers like online learning, where students were working from home. We saw our video game customers really scale as people were playing more and more video games. And we saw our video streaming customers really scale dramatically as people spent a lot of time at home watching video streaming. So what we were able to do, we've got a lot of capacity on the ground. We've got a lot of capacity in the supply chain at any one time. And what we're able to do is very dynamically reconfigure the supply that's on the ground, reconfigure what's happening in the supply chain to be able to redirect from one region or to another, to make sure that we were able to quickly adjust to where we were seeing the daily and weekly spikes in demand, where the capacity was actually needed, and we were able to reconfigure and redirect supply to those places.
Excellent. And so Scott, one of the things we often say, and I mentioned earlier in the talk, is there's no compression algorithm for experience. And these models that you talk about is something that we've delivered and developed over many, many years in AWS, and then our scale helps us to meet this demand. And so coming back to on the onset of the pandemic, what did you and your team do, or did you do anything specific to make sure that customers have business continuity during these unprecedented times?
Yeah, we immediately started making changes to our demand planning to be able to buffer for additional capacity. We knew that customers were going to need more capacity, so we immediately started changing our models. We also work closely with our infrastructure partners, where some countries may be harder hit by COVID. We were able to redirect our orders for hardware and racks from some countries that were having struggles with COVID to other countries that were not having as much problems, to be able to, inside the supply chain, redirect where that capacity was coming from. So our infrastructure partners did a fantastic job working with those manufacturers to make sure that we saw very little impact from COVID, but it wasn't for lack of hard work. Those guys were working really hard to make sure that the capacity ended up where it needed to be.
It's amazing what the teams were able to achieve. Now, Scott, are there any specific customer examples that you can call out where we were able to help customers with capacity needs?
Yeah, let me talk about online learning. So we have a customer, Blackboard. Blackboard provides a video learning capability for their customers, for schools. And as you can imagine, the scale, they jumped up quite a bit, almost 50 times what their normal scale would see. So that and then practically happened overnight. So we worked very closely with Blackboard. Again, our scale really allowed us to be able to reconfigure and get capacity built out and configured in the sizes and the families that they needed. So we were able to do that. The other thing that we did was work closely with Blackboard to provide additional flexibility. So before they had a single instance type that they could use, we worked with them to qualify 2 or 3 different instance types, which really allowed them to expand the amount of capacity that they could scale into, which helped because they didn't have a lot of visibility into how high they would actually go. So we really were able to work closely with them and stay ahead of any of the different spikes as they went from, saw spikes in Europe for one part of the day, saw spikes in Middle East for the other part of the day, and then finally spikes in the US. And we were able to provide the capacity that they needed so that they had a very successful COVID experience.
Fantastic. Well, that's a great example, Scott, and thanks for sharing that. And thanks for joining me today to share a little bit of the details behind the scenes of what we had to do on the capacity side to make sure that we met the demand from our customers during this year. Thank you.
My pleasure.
It's just incredible what the teams were able to achieve during these challenging times. And it was fantastic to be able to help support so many of our customers as demand for their businesses spiked. Next, let's take a look at some of the critical business workloads that we needed to support during the pandemic. One of my favorite all-time sports is Formula One, and it's a lot of fun working with them on critical innovations within the sport. With the pandemic, there was limited access to wind tunnels, so all design has to move to high-performance computing workloads running computational fluid dynamics. Formula One utilized over 12,000 hours of compute time in designing the car for the 2021 racing season. As Pat calls out in this quote, the project was one of the most revolutionary in the history of Formula One aerodynamics, but they were also able to reduce the runtime from 60 hours to just 10 hours by using our latest compute-optimized instances with 100 gigabits of networking throughput. To run and scale workloads like this, we bring together the latest compute, networking, storage, security, and cloud orchestration to offer a secure, highly customizable, and cost-effective high-performance computing platform. Over the last 2 years, we've invested significantly to provide a great foundation for HPC, and as a result, the industry has recognized AWS as a proven leader for HPC in the cloud, awarding us Best HPC Cloud Platform for 3 years running. And now, let's take a look at another high-scale workload that requires tremendous compute power and something that I'm sure we all are well familiar with.
Weta is the ultimate world builder. To deliver these films, it takes tremendous talent, bespoke software, and enormous compute power. Our compute needs have drastically increased. Also, remote working has become an important component of our future. That's why with AWS, we are taking over 150 proprietary tools and creating a robust Weta cloud-based pipeline. Weta can then hire any artist around the world and power them with our tool sets and nearly infinite compute to continue our filmmaking magic.
Wow, it's amazing to see what Weta have been doing with the power of AWS. So we've covered capacity and scale. Let's take a closer look at optimization. Across all workloads, cost has been at the top of customers' minds this past year. Many customers had to face the trade-off of driving innovation or reducing cost. Our focus has been to help customers do both. With graphics-intensive applications growing in popularity on AWS, we thought we should take a look at optimizing access to GPUs. So yesterday, in Andy's keynote, we announced G4AD, offering the best price performance for graphics-intensive workloads in the cloud. Powered by AMD's second-generation EPYC processors and their latest AMD Radeon Pro V520 GPUs for applications like remote workstations, game streaming, and rendering. Just incredible. I wanted to look back to our AMD portfolio of instances, much of which has been focused on providing you with fantastic performance at 10% or more cost savings for x86 workloads. Since our very first AMD instances in 2018, we have steadily grown the portfolio, and it has been a great partnership with the team at AMD. Earlier this week, I caught up with Lisa Su, President and CEO of AMD, to discuss our partnership and some of our recent launches, and what all of that means to AMD customers. Let's take a look. Well, welcome, Lisa, and thank you for joining me today. You know, AMD is a valued partner, and today we now have 9 EC2 instance families spanning more than 20 global regions powered by the AMD EPYC processors. And countless number of our customers are seeing great value and performance in AMD-powered EC2 instances.
Thank you, Dave, for the opportunity to be here. And AWS is a very key partner for AMD, and we've had such a strong partnership over the last few years. Our mission at AMD is really to push the envelope on high-performance computing products. And with AWS together, we're offering tremendous compute capability to our joint customers.
AWS first announced the AMD-based EC2 instances in 2018 and delivered 10% lower costs to customers in our core EC2 general purpose and memory optimized instance families. Lisa, from an AMD perspective, how easy was it to get AMD up and running in the cloud?
Well, Dave, I think we have 2 very strong teams, on our side, designing the products, and on your side, really bringing compute to the marketplace very quickly and efficiently. So, we've been able to see just a seamless transition for AWS customers to move workloads to AMD-based instances with our x86 code compatibility. And with our high-performance CPUs, customers can transition to these AMD instances and get much better value in the process. So whether you're talking about AI or database and analytics, we've seen some great results. So we're very excited about what we've been able to accomplish together.
Well, Lisa, the reception for AMD instances has been overwhelmingly positive. Customers like the 10% lower costs, the application compatibility, and the seamless migration experience for x86 workloads. In fact, they wanted more. And so earlier this year, we introduced compute-optimized C5a and C5d instances powered by the second-generation AMD EPYC processors. Lisa, How has that been an important instance for AMD and your customers?
Yeah, so we're very excited about the expansion in the portfolio with AWS. We have 3 different types of AMD-powered instances to meet general purpose needs, memory optimized needs, as well as the new C5a instances around compute optimization. And it really helped to fill out the overall portfolio. I would say, again, this is a great example of our joint collaboration to bring the highest performance x86 processors to AWS customers. And we've had a number of industry leaders already adopt C5a, including Airbnb, Expedia, and Capital One. And I know that our customers are always looking for more, so it's just a great opportunity.
Yes, and in fact, in Andy's keynote this week, we referenced that we're bringing AMD GPUs to the cloud with the EC2 G4AD instances. G4AD instances feature both the 2nd generation AMD EPYC CPUs as well as the AMD Radeon Pro GPUs, and provides customers with up to 45% better price performance in the cloud for graphics workloads.
Yeah, it's very, very exciting. So, key expansion. And when you think about 45%, it is a big number with tremendous value for our customers. I think our goal is to provide the best price performance for graphics intensive applications here in the cloud. And whether you're talking about remote graphics workstations or the virtual desktop VDI environments or video transcoding or some of these photorealistic design applications or even game streaming, all of these applications need high performance graphics. And we're proud to partner with AWS in this space.
And certainly, we've seen high demand for graphics workloads, and this is another way to help customers reduce costs with just a few lines of code.
Look, I think, it's really just amazing to see how much we've been able to accomplish in our partnership over the last few years, Dave. I think the innovation, the collaboration, the focus on what our joint customers need has been fantastic. And I really look forward to doing even more together in the future.
Well, Lisa, I want to thank you for joining us today. It's been an incredible partnership over the last 2 years, and I look forward to everything else we're going to do together going forward. Thank you.
Fantastic. It was great being here, Dave.
It's amazing to see what we have been able to achieve together in just a little more than 2 years. We're looking forward to what the future holds here. With many customers working remotely this year, more than ever, we have seen customers rethinking where traditional applications live and how they can make the cloud their primary model for all applications. Due to health and safety concerns for their IT staff, companies have struggled with maintenance or adding compute and storage capacity. More than ever, customers are thinking about how they can have a fully managed infrastructure model, like they do in the cloud, for applications that need to remain on premises. But before we get there, let's take a look at our global infrastructure. Footprint and reliability matter, and we have the broadest footprint of networking services around the world that make it easy to connect into the cloud more than any other provider. Currently, AWS offers the most multi-AZ regions in the cloud, which is 2 times more than the next largest provider. We have a high operational bar for our regions, so unlike other providers, we do not build regions with only a single availability zone. Also, our availability zones are placed at a distance apart to prevent the chance of correlated failure. It's really interesting to see where other providers have cut corners in this critical area. So once again, I encourage you to catch Peter's keynote next week, Thursday, for more details. The AWS backbone spans the globe and carries all traffic between our regions, CloudFront POPs and Direct Connect edge locations. Every fiber here is controlled by Amazon and is either leased or owned. Importantly, all of this infrastructure can be used to bring the cloud closer to you. Customers have a continuum of workload types, some of which can easily be moved to AWS regions, some of which are harder due to data residency regulations, and some that need to remain on premises or at the edge for the foreseeable future due to low latency and local data processing requirements. This year, and especially this year, the world is a bigger place but also a smaller one. For some industries, like real-time multiplayer gaming, latency rarely matters, and having compute capacity as close to the users is critical for performance. Also, some governments have more governance over industries in healthcare, financial services, and require applications for those services to stay within their borders. All of these are examples of industries that we have been working with to extend the cloud to service their needs. In this section, we're going to take a look at 3 areas. First, AWS Outposts, bringing AWS infrastructure to virtually any data center, co-location space, or on-premises facility. Second, AWS Local Zones, bringing AWS services to large population centers. And finally, our third offering, AWS Wavelength, bringing AWS services to mobile edge computing locations within 5G mobile networks. Let's kick it off with AWS Outposts. We announced Outposts at reInvent last year, and it's been a big year. Customers have loved the offering, providing the same AWS-designed infrastructure within their own data centers. In the last year, we have expanded to 51 countries and significantly expanded the available services on Outposts, including RDS, ALB, EMR, Elasticache, and more recently, S3. And customers have been able to quickly migrate workloads to the Outposts through the single management plane in the cloud. I recently caught up with Meena Gowda, Principal Product Manager of AWS Outposts, to hear more about what the Outposts team has been up to. Let's take a closer look. Welcome, Meena, and thank you very much for joining me today. We launched Outposts a little over a year ago now at reInvent last year. And I'm interested to hear, what are you hearing from customers on Outposts, especially during COVID?
Thank you, Dave. Today, more than ever, customers recognize they want more agility in their infrastructure and are looking for pathways to get them to a common and fully managed cloud model, even for their on-premises environment. Outposts is a way for them to achieve that goal and accelerate their migration to AWS. Customers love that they deploy and manage apps just like in AWS. We deliver and install and set up Outposts for our customers, and they're up and running in just a few hours.
That's amazing. And can you take us through some of the key use cases that you see customers doing with Outposts?
Sure. Some of the key use cases we see are low latency, local data processing, data residency use cases, and cloud migration as well. And we're seeing adoption across the globe in a broad number of industries: manufacturing, healthcare, gaming, financial services, media and entertainment, and many others. For example, Riot Games, they are an AWS customer, had a global launch of their multiplayer fast action game called Valorant under a very tight deployment timeline. Customers like Riot wanted to ensure an engaging, high-quality experience for all their players across the globe, even in countries and metro areas far from AWS regions. Riot Games was able to deploy Outposts in 4 cities across 3 countries globally to support their game launch.
Wow, that's incredible. And the amount of time that they did that in as well was just incredible, fantastic. Now, when we launched Outposts at reInvent last year, we had a number of AWS services available on Outposts, and we've added a number of them over the last year. And one of the ones we added recently was S3 on Outposts. And can you take us through what new opportunity has S3 on Outposts opened up for customers?
Absolutely. S3 on Outposts adds another storage option in addition to EBS to even better serve our customers' data residency use case and local data processing needs. Customers can use S3 APIs that they're already familiar with, and they can add up to 96 terabyte of storage capacity to an existing Outpost. S3 on Outposts helps address use cases where customers need to keep their data within a country or a state or any regulated area where there's no AWS region today. It also helps customers with address use cases where they have applications that require high throughput local processing, such as medical imaging in hospitals or autonomous vehicles, data processing, and manufacturing systems.
That's great to hear. And now, partners play such a critical role in developing on-premise customer solutions with Outposts. And can you take us through a little bit about what we've been doing with partners to build a partner ecosystem for Outposts?
Yeah, our partners are very excited to bring their solution and services on Outposts. We have an APN consulting partner program composed of partners who provide system integration, consulting, and implementation services and solutions. We launched an AWS Outposts Ready program in September this year with 32 technology and ISV partners. in just the last couple of months, the number of partners who are certified under this program have more than doubled. We're super excited to see the momentum here. Outpost Ready partners fully test their solution on Outposts. They follow the AWS security and architecture best practices as part of the program.
Well, that's amazing. Now, I'm sure one of the questions everybody's interested in is what's next on the roadmap for Outposts?
So today, Outposts is available in 51 countries, 22 AWS regions, and we're not stopping there. We're continuing to roll out new countries and regions to meet our customer demand. We have launched 8 AWS services. We have load balancers, RDS, ECS, EKS. We talked about S3. And we will have more options in the next year that provide more flexibility for a broad range of customer applications. The technology and learnings from Outposts enable us to innovate and deliver new form factors to address additional use cases like Outposts in hospitals, manufacturing plants, and retail locations where space is constrained.
Well, Meena, thank you very much for coming to talk to us. It's amazing to see how much progress we've made just in 1 year on Outposts. I know that next year is going to be just as good. So thanks again for coming in. Wow, such a great update. And I'm super excited with the use cases that customers are solving with Outposts. It really is a dynamic offering that allows you to bring the fully managed AWS cloud into your own on-premise facility. With that said, earlier today we announced AWS Outposts in 2 new sizes. These will be available in both 1U and 2U form factors, specifically designed for smaller compute workloads and to fit into industry standard racks. We have also simplified the installation process to allow either your own team or a third party to install the device. Both sizes will provide 64 virtual CPUs, 128 gigabit memory, and 4 terabytes of local NVMe storage. And, as with the full Outpost rack, these new form factors offer the same AWS infrastructure, services, APIs, and tools. These are going to be great for retail stores, offices, hospitals, and other locations where only a few servers are needed. Let's talk a little bit about AWS Local Zones. Local Zones are a new type of AWS infrastructure deployment that places AWS compute, storage, databases, and other select services closer to large population centers where no AWS region exists today. Also, local zones are fully managed by AWS, so customers do not need to think about the data center or capacity management. Last year, we announced local zones, and we now have 2 local zones in Los Angeles for highly available applications. Netflix and Mindbody are 2 examples of customers achieving low latency for their applications through the Los Angeles local zones. We have also seen continued need from customers for bringing compute closer to other US areas for applications which need lower latency. And thus, we just announced the availability of 3 additional local zones in Boston, Houston, and Miami that are available in preview today. And we will launch 12 more local zones in major metropolitan areas in 2021 to help customers achieve single-digit millisecond latencies across the United States. Finally, AWS Wavelength is an AWS infrastructure offering optimized for mobile edge computing applications within 5G networks. 5G is here. The iPhone 12 is a 5G device, and all the other major manufacturers offer a 5G-capable phone. Telecom operators worldwide are investing billions of dollars to roll out 5G networks. 5G wireless technology is designed to deliver almost 10 times LTE peak data speeds, ultra-low latency, more reliability, and massive network capacity. The combination of all these factors will help 5G drive innovation in many industries, from augmented and virtual reality, autonomous vehicles, smart cities, to remote healthcare. 5G opens the door for so many opportunities to develop new, innovative applications, and we're excited to see what our customers do with AWS Wavelength. Wavelength places AWS infrastructure at the 5G network edge to eliminate the extra network hops and makes AWS services, APIs, and tools available to developers to build, deploy, and manage the latency-sensitive components of their applications at the 5G edge, just like they do in AWS regions. Wavelength became generally available in August with Verizon, and we have 7 wavelength zones across the US. Today, I'm excited to announce an 8th wavelength zone with Verizon in Las Vegas. And we continue to partner with Verizon, KDDI, SK Telecom, and Vodafone to bring AWS wavelengths to countries around the world. Taking a step back, we have the broadest portfolio of options to bring AWS services to where you need them for all of your applications, delivering the same AWS experience. Our mission is to build the compute platform for every workload, and our goal has been to help businesses of all shapes and sizes not just survive, but thrive. We continue to build the cloud for scale, price performance, and security with the global coverage you need for all your applications. While we are not together in Vegas, I encourage you to take advantage of all the power that a virtual reInvent offers. Over 3 weeks in December and in January, you have the opportunity to attend all the sessions you want with a front row seat. Join online and find what sessions you need, and we'll be here. In addition to Swami's ML keynote and Peter's infrastructure keynote, here are a few compute sessions that I would highly recommend. Have a great reInvent, and thank you for trusting AWS with your business.